In this question, I'm told that AOB is a diameter. Okay, but this is also not quite what I've seen before because it's not a full circle, is it? It's a semicircle. So that means I can't have a cyclic quad. So all of the theorems to do with cyclic quads are not options here. Okay, so let's see. I've got this diameter. Does the diameter make 90 degrees? It does. So let's go and put that in. There's my 90. Okay. Does the diameter give me a whole bunch of radii? It does. Look there. There's this one, and that one, and that one, and that one. So what's entering my mind right now is this idea of writing down too much. And I know I'm going to have a bunch of angles opposite equal radii, and I'm just not sure now which ones are going to be useful. So I'm going to make a little note here to myself, okay? And I'm going to just say radii. So I can come back to any one of those four and handle the fact that, you see there, N2 equals B1 plus B2. I see there's an X there, so maybe that's going to be helpful. N1 also equals M3 and 2, and then angle A equals M1 plus just M1. Okay, so there's a whole lot of things here, and I'm just not sure I'm going to have to deal with all of them. So I'm just making a note that I can come back to it and fill in the ones that are useful. So the diameter, does it give me a center? It does. And that's how I got the radii, right? What's the other thing I'm supposed to look at for center? Well, radius to tangent, but there's no tangent, so no. And then there was angle at center equals twice angle at circumference. Are there any of those? Okay, MN seems to be making an angle at the center. And then MN also makes B2. Okay, so that means this is two B2s. Okay, I'm probably going to replace that with something later. I think I've covered most of what the diameter can give me. I know it's a semicircle. I've been very alerted to the fact that this is different. So I think I've put stuff down to do with semicircle. Also, the use of the word semicircle helps us find that 90, which we got. Now I'm told MO is parallel to NB. And let's see if there's any fun angles going on. Pity about a screen is I can't turn it sideways. Anyway, I always like to do that when it's an actual piece of paper. Okay, let's see. My N2 here would be the same as what I've just done as 2B2. Okay, so I've done a single bar there, so I'll keep it like that. But I've got an X in the middle, so that means I've got another set of alternate angles. So that means that B2, let's give that a double bar. B2 will be the same as M2, this little one here, the one that's within the 90. Okay, two sets of alternate angles. Be careful now not to see MN as parallel to OB. I mean, it might well be, but we can't prove it. And we don't have to yet. Okay, B1 is X. Good, yes, got that, going over the X. And then what we had to do is express all of these angles, M2, B2, and so on, in terms of X. And the first thing I notice is that the M2, I haven't marked out with any X. In fact, I haven't put anything with X. And now I need to go back to this radii thing. Because actually, MO and BO are radii, and they're making this triangle MBO, right? So that means that M2 is X because of angles opposite equal radii. Okay, hang on a second. I marked that as a double bar, which means B2 is also X. That's alternate angles. Okay, so M2 is X, and that was angles opposite equal radii. And then that linked to B2, and you can see these questions scaffold beautifully. The one leads to the next one, so you do want to do them in order. It's pretty much the only section in maths you really want to do in order. B2 is x, and that's because of alternate angles. Now they want O2. I put something by O2. I said it was 2 of B2, but B2 is now x. Okay, so I'm going to scratch that out, and I'm just going to say 2x. What was the reason again? It was angle at center. N2 I marked as a single bar, which is the same as O2. Alright, that'll work. So N2, I just want to say there, equals O2 equals 2x, and then the reason there was also alternate angles. And then K1, where is K1? K1's here. Okay, so I'm thinking about K1. I shouldn't mark it as, I'm going to mark it as an extra thick one so I don't confuse it with my other little bars. Okay, K1, something to do with x. Let me just go and put N2 as 2x there. K1 is an exterior angle of this triangle NBK. So K1 is going to equal 2x plus x because of exterior angles of a triangle. Okay. I'm going to name the triangle NBK. Then I'm told that x is 30. So in the next question, I'm told that x is 30. Now I can't use that earlier, but I'm supposed to use it now. Okay. So the first thing that I'm going to go and do is add in a couple of numbers. So, okay, that's 30 there, and that one's 30. That'll be 60, which is, this is 60. That is 30. Okay. K1 was 3x. Oh, I should have finished that there. Sorry, that's 3x. K1 is 90. Oh, that is a 90. So K2 is 90, right? Are you seeing anything interesting here? So look, you've got this thing, this line is coming from O to N. And it's going from the center and it's perpendicular to a chord. Look at that. So that means these guys are equal to each other. Alright, that was a bit of a tangent there. Not a geometrical one, but a thought process one. X is 30. I've got the 90, I've got the 60 and the 30. What do they want? They want the angles of M, N, K. I'm going to just go over that triangle. So it looks a hell of a lot like N1 is going to be a 60 and M3 is going to be a 30. But it's going to be quite difficult to prove it. The thing is, I'm told about parallel lines. I'm told that NB is parallel to MO. And I've also got this MK being equal to KB. Why am I suddenly working with sides now? So I've mentioned before that congruency is useful everywhere. And it seemed like rather a long process to go through here. I'm definitely seeing a parallelogram in MNBO, but I can't quite see clearing to prove it at the moment. So I guess without being able to do that, I can't see. I've got MO is equal to BO, and I've got that MO is parallel to NB, but I can't prove that they're all equal sides. So this is an example of where I can see where this is going. I'm also looking at the question and seeing I've got to prove that that's a rhombus. I'm seeing a kite. I definitely see a kite because MO equals OB, and then the diagonals bisect at 90 over here. I've definitely got a kite. So I will get a rhombus, but I'm going to need to go through congruency to be able to prove the M3 and the N1. Okay, so it's useful. Sometimes it takes longer, but congruency is something we can all do. So therefore, if it helps you, go ahead. In triangle MKN and triangle BKN, what I have is, there's also this common side here, okay? So I'm going to say KN equals KN common. I've got the angle K1 equals K2. I'm going to say adjacent supplementary there, or angles on a straight line. And then I've got the ones that I got from the line perpendicular from the center to the chord. So my MK equals BK, and it was, what did I have? I had line from center perpendicular to chord, because that then gives me the fact that they're equal to each other. Okay, once I've got the congruency proven, I can then put in the angles that gives me. So therefore triangle MKN is completely congruent to BKN. It was side, angle, side, and then therefore from that, I can say that M3 equals B2, which is 30, and then also N1 equals N2, which equals 60. And then I'm immediately going to go and put those on the diagram. My M3 is 30, my N1 is 60. Because I know what's coming now, it's this rhombus thing. Okay, so what are the properties of a rhombus? So I'm going to start with the fact that Mn equals Nb, and that's the congruency that I've just proven. So I've got those sides are equal to each other, and I've also got MO and OB because of radii. So I've got two pairs of those sides that are the same. Now I just need to prove that they're equal to each other, and then I've got all sides are equal. And I'm going to get that from the fact that my 2x here is 60, and my N1 is also 60. So I'm going to say that MO equals MN because they are sides opposite equal angles. Okay, so then all of the ones that I've marked up with one stick or this curly thing, they're all the same now. Okay, and therefore I have the sides all equal. Okay, so therefore all sides of MNBO are equal. I also have the diagonals bisecting. So remember that a square is a rhombus, and all sides could make it a square, but it doesn't. And that's actually enough. If you've got all four sides equal, then you have a rhombus.